Can we keep quiet?
If you call the question what? If you call the first term or member, the first term or member, we are looking at each term and the term of a member. Right? I have skipped one area about relations of which I know. You did something about set theory, where you are coming from. You did something about a set, where you have to look at elements or members within a particular set. You can have two sets, you can have a set with elements or members. And again, I remember that you did something about intersection and union within a set, which I have omitted that. So I've just gone direct to this issue. Now that issue where you did set theories, where you had elements within the particular set, that is what we call relations. So you can revisit that based on your own knowledge from the secondary school. But I have just gone direct to this issue of what is called functions. Functions. And again, this issue on functions, you can get it through again. You have learned this at LXE, where, if you recall, you learned something about domain and a range. Where in domain, you are looking at the things which is an input, and a range is something which is an output. So you have the two issues, a domain and a range. That is again in connection to if you know how to substitute. If you know substitution, that you like at LXE, it's easier for you to find the domain and the range. So there are two issues here. We are looking at the domain and we are looking at the range. So it works more or less like a machine. That's why there's this issue where they're saying every input produces only one output. What does that mean? It means when you look at when you have an input, the result that will come out of that is an output, and that's one output. Whatever you are doing, it has got a consequence at the end, and that's the output. Right? The input is what you are putting in. Assuming you are in an organization, where in that organization, your aim is to produce products or come up with goods and services. So in that organization, you involve raw materials. You know what raw materials do come from the soil and whatsoever, from the natural resources, right? And you know what natural resources, everything that is provided by nature. Now, the fact that you have got those natural resources, whatever, they are raw materials. When you take the raw materials and you put them into your organization, company, manufacturing industry, you do all the processes, the end result will be the output. And it is this output that is the value you want. If we customers value our product, we value the output. We don't value the input. Right? People can grow cotton. That is the input. Because those are the raw materials. Cotton. And that cotton has to go to gineries and whatsoever or factories. And this is a function. And the cotton, when it comes out there, what we admire is the cloth that will come out of that. We say this cloth has come from the cotton. And that is the output. That's why in mathematics or in business math, this is in line with the input and the output and the function. The function is the process that is happening between the input and the output. In other words, this input is the domain and the output it is the range. So when I'm talking about the domain and range, what I'm talking about is the input. So the input, this one, is the domain. So I'm regarding this as the domain here. So this is the domain. And here what is happening here, they are the processes. So you have all these are the processes, and what is coming out of this is the range. Range is the real product that is coming out of that. Can you stop playing with your phone? Someone is busy on WhatsApp. We have again phone, but you have left it. Yes. Can you just take it out? Alright, let's proceed with what we are looking at now. Let's represent this in terms of domain and range using functions. Yes? your head. That's the input. Right? You process that based on your behavior and what, right? And then the final thing, which is the output, will be seen wherever you go. Because wherever you will be waiting, they will say this is a very good one, game. And which school are you coming from? Oh, I learned that this, right? That's the output. So what we are saying is when you talk about the input, you are looking at, if this is the, let's talk about this as a function. The input, you are looking at the input as raw materials. You know what raw materials? Raw materials. Hey, tons as the raw material, right? Tons as the raw material. Then you take tons, you take that tons, move it to factory, right? And then after the factory, that tons, they will process it. The processing, they make it a function, right? You have a process, if you are doing and that is how is the output, right? And that output, it is now what is called the range. Right? That range is the output. And that's why we are considering it as X and Y. In other words, for everything, for you to produce Y, it depends on the X. So we have this one as a dependent variable, and this is an independent what? Variable. So we have got dependent variable and independent variable. Because for you to produce here, you depend on the X. Therefore, we have got dependent variable and independent variable, which you are going to be learning that as you go around your 4th year. That way, the dependent and independent will be there with all the lectures. Right? But now I'm not talking about whatever is there. So I'm saying that input is what is called the domain. And the process is the function. The end result there is the range. I'll give you an example to show that what I'm talking about. Maybe if you haven't understood that, let me just give you an example here. But what I'm saying, what I'm talking about the function, it is coming from, you need to have a knowledge about substitution. You know how to substitute? Yes. Assuming A is 1, B is 2, find A, B. You need to know how to substitute. 2A plus 2B. Provided you know how to substitute, these things there will be very easy for you. Let's proceed. Element here. Let's go to this element. We are having about a function. A function is usually represented as the f. So when you have got an f means it's a function. When you see an f, here it is a function. So when you have an m, that is a function. As we have already seen above that diagram, when f acted on input, which is an x, we get y as the output. So very often we write y is equal to function of x. So if you want to read this, when you have got this, it means y is the function of x. That's how we read it. In other words, f of x is the same as y. So this is y is the function of x. F of x is the same as y. If you remember, sometimes you have something like this. You have something like that. This is y and this is x. Cartesian plane. Something like that. So you have the y and this is your that you have the x. It means what it means that if you want to write this y is the same as writing f of what? F of x means y. It means that is y. What does that mean? Any value of y, it has an impact on x. Therefore, we say f of x. That's what we are writing. So y is equal to f of x. To represent a function, it means this is a function of y. Function of y is equal to f of x. Right? We can also use arrow diagrams to represent a function. Now let us have two sets. Actually, we are going to set x and set y. Then f, the function, is called a function from the set x to the set y. And this can be written as this. So the way you can write it is the same as that. F is the function of x maps to y. This is how you read it. You say function of x it maps to y. But this one is y is a function of x. But if you want to read this, it means function of x maps to y. So it is function of x maps to y. If every element of x has one arrow, it is the coming arrow coming out of it. So every element of x has got an arrow, the other arrow going to the other side. Let me just write this as an example now. Yes. Example. Assuming we have got this to set x, and this set x has got this element a, b, and c. And again we have got set y, it has got elements like 1, 2, 3, and 4. 1, 2, 3, and 4. These are members within the set. And they are called elements. They are called elements, but this is the set. Set x has got members 1, 2, 3. In other words, this is the house. House x has got 3 people. House y has got 4 people. That's the meaning of that. And these people are elements. We are elements here comprising of this set. This is the set. Right? And again, let us draw an arrow diagram. So an arrow diagram will be like this. So arrow diagram of the function f from x to y, from x to y will be something like this. Set x is this one. Set y will be this one. So this is set x and this is set y. Elements here, they are 1, 2, 3. So you have got a, B, C. Right? Elements here, I've got 1, 2, 3, 4. Right? So it's up to you. You can represent that. Set this A that the mark is depends. It depends. If you want to set B, you can mark whichever you want. It depends on what you are mapping. You can take it if this one is mapping into this. It means that there is one element without being mapped. So the way you do it like this one, that is what is called mapping. So in fact, if you look at this example, this is what is called a domain. So this is what is called a domain, and this is what is called a range. This is a domain, and that is a range. So the range there, if you look at this one, the range, it is a set of, the one that is mapped. Range is a set of 1, 2, and 3. Domain is a set of, domain is a set of A, B, and C. But now, you look at this one. So, what the domain, it maps to a range. Domain maps to a range. Domain, it maps to a range. So the range is those elements which have been mapped. But if you look at this one, there is one element which is not there, and this is the 4. Therefore, if you look at it, if I happen to come up with this which is the y, 1, 2, 3, 4. This y, which is 1, 2, 3, 4, the whole of this set is what is called domain. So, yeah. Yeah, let me just write. So y is equal to set of 1, 2, 3, 4, and this is what is called domain. Right. What I'm saying is, we have two sets here. Set A and set B. Set A or set X has this element. Set Y has this element. Now, by our definition, we are saying that these ones they have to represent the functions into the other one into the range. Therefore, our X is drawn by diagram. You have X, A, B, C, and this is our domain. X is the domain always. Our range is the Y. The whole of this is the range. Right now, if you look at that, you have A. A is mapped. You can map it to 1. B, you can map it to whichever. And you say you can map it to whatever. If they are mapping, you discover that one is not mapped at all. Therefore, the one that is not mapped at all those elements within that, because they are looking at one which is not mapped, like this one, the whole of this which is not mapped, because these are the codomains. For that as a codomain, it simply means that after you have the domain and the range, and you discover that there is an element somewhere which is not represented, and here it is 4. Therefore, the whole that set is what is called the codomain. Right? We are learning this. What is the importance of learning this?
Yeah.
When you get. Okay. Yeah, very good. What will happen if all it has mapped like that, right? Yeah, that it has mapped. This is what it means, it has mapped. It has, A has mapped to this, B has mapped to that, so it has mapped. Right, let me just give you an example, maybe for your one. Let me just, no, it wants to be for domain. It has been mapped. You have mapped it. Which one? Why are you saying that it is a codomain? Yeah, it has not been done. Now, if it happens that maybe everything has been mapped, yes. So it's fine. What can you mean? Okay, that's good. No, it's not that when you map, that doesn't mean that you just map based on your phone. That's why I'm saying, let me give you an example. Right? Let me give it. It's not that when you are mapping, you just map when you as the way you do it. Let me just give you an example. That's why when I introduce this one, I can say, you need to have an idea about what is called substitution. Right? Yeah. Let me just give you this example. This is just an example to illustrate domain and range. But let me just give you this one. Assuming you have y is equal to 3x plus 1. No, I'm not example 2. I'm trying to find out from her and from that one, because as I said, what is that one is not mapped, right? And she has said, why do you choose that? You just dream, you are going to map like that. You can say no. They are always doing good, right? And if that this is the function, y is the function. In other words, if it is the function, it's the same as saying f of what? X is the function. And this function is equal to 3x plus what? Plus 1. Right? Then what to write to find the domain and range? Right? Domain and range. Assuming we have got this. What to find domain and what? Range. Like this. Right? And our function that maps that to that. Because the function it maps, it goes like that, right? The function is this. F of x is equal to 3x plus what? Plus 1. Assuming we are given the domain. We are given the domain like minus 3, minus 2, 1, 0, 1, and 2. Right? Actually, we are given this as the domain, right? We want to find the range. What will this map to this element, right? What will this map to there, right? What will this map to there, right? What will this map to there? We want to find the elements there, right? Now, if you want to find the elements that are going to put it there, you substitute. You take this negative 2, right? So that's why I'm saying that this is the same as x. And this is the same as what? Y. Where there is the x, you put this number and you find the value of the y. So here is the same as it. Where there is x, you put what? It's the same as here. F of negative 2. What will be that? If you put f of negative 2, where there is x, you put negative 2. This means 3 times negative what? Negative, which is negative what? Negative 6. Negative 6 positive 1. Negative 5. Therefore, yes, there will be negative what? 5. It has mapped there. Right? Then, f of 0. So you put f of what? 0. Here. So f of